Hello everyone, welcome to OneClass channel. My name is Devansh, and today we'll go through a couple of pre-calculus problems. And I think that these problems will be at high school and university level. I'm not sure that um, you'll get these problems at middle school level, but anything can happen. So a little bit background about myself. So I'm in the final year of my graduation, and I'm doing my graduation in aerospace engineering. And if you need any tutoring help or if you need any one-to-one live sessions, then you can always check the links in the description below. And so, without wasting your time, let's just begin with our lesson today. So, I guess uh, everything is visible right now. I'll just start my lesson. So, we have the first question for today, and that is question number one. So for each of the following exponential, identify the initial starting value, the growth factor, and state whether the equation represents exponential growth or exponential decay. Okay, so we have two equations. I'll start with the first one. So f of x is 420.2 0.68 power x. We need to find the initial or starting value, and we need to find the growth or decay factor. So the thing is that I'll just take the reference. Okay, yeah. So let's say we have a function y equal to, let's say it is a 1 plus r power x, and let's say y is a 1 minus r power x. I just a minute, the initial value. Okay, yeah. So in the case where we have a positive sign here, it will be the growth, and for the case where we'll have a negative sign in this, it is going to be a decay, and this a is going to be our initial value. Initial value. I don't know why my handwriting is not looking good. Yeah. So in the first one, we have been given with a function, but the thing is that this function is not in this kind of form. So basically, it should have one. Like we need to equate this 0.68 is equal to 1. Let's say plus x. Then what I'll do, I'll just take x on this side, and I'll bring 0.68 on this side. So it will become negative of x equal to, this will become 1 minus 0.68, and this will be 1 minus 0.68, 0.32. This means x will be minus 0.32. Now the thing is that we were taking the case of growth because um, like if we are taking a positive sign, and if it is negative, then it will become negative. But if we are starting with the negative sign, then later on it will become positive, and it can like change your solution. So it is better to take 1 plus x equal to the number inside the bracket, such that you'll get the magnitude as well as the sign of the this number. So if I just put x equal to minus 0.32, then it will correspond to the case of decay. So I can write f of x as 420.2, 1, then this x will become minus 0.32, and yeah, obviously raised to power x. So don't get confused with this power x and this x. I just let me correct this, I'll just write this as y, not y in fact. I'll give it another value z. Let's just say z. Or yeah, I think let's just say it as r because we have already used r. I'll say that 1 plus r and r. So the first one we have formed in this general kind of, we have just converted this equation in general form. Now we can say initial value. So initial value is 420.2 and it is obviously the decaying function. The rate of decay we can say from here. So the decay factor is going to be the number inside this bracket. So decay factor is 0.68 here. Same procedure we are going to follow with the B part. Uh, just add a page here. Yeah, what was the equation B? A of t. Okay, so here a function of t is given as 0.77, 4.91 raised to the power t. So again I'll just write 4.91 equal to 1 plus r, then r will come here and this will go there, so this will become r equal to 1 minus 4.91 and this will become minus r will become minus 3.91 and I could just divide both the sides with -1, so this will become positive and therefore my r will be positive here. So I can write this as a of t is 0.77 and this will be 1 plus 3.91. So again we have a positive sign here, so we'll have the growth factor here. And the initial value. So the initial value will be 0.77, the value outside the bracket. And let me just check the growth factor. Yeah, so the growth factor also they have given the correct one, which is 4.91. Again I'm saying that this in terms of 1 plus the number, we are writing it in this term because we just need to verify that whether it will get a growth factor or a decay factor. But the growth factor or we'll get a growth function or decaying function. But the thing is that to get the growth factor, um, we'll just take the value inside the bracket. So this is the value, I guess. And okay, so there is nothing much left for this question, so I'll just say that correct solution. And nice work. Obviously appreciation is very much important. Mm. Okay, so now this was I guess, yeah, this was first question. We'll start with the next one. I just want to add a page. So this one is question number 2 and it is asking that how do you find the exact value of sine inverse of half. So sine inverse of half or 1 by 2. What is it? So the thing is that let's say sine inverse of 1 by 2 is obviously going to give us an angle. So let's say that sine inverse of 1 over 2 is equal to theta. Like in the solution they have solved using graphical method, but like if you do not have a graph with you, then you can follow this procedure. So this is sine inverse, yeah, sine inverse of half is equal to theta. we'll just operate sine on both the sides. So it will become sine inverse of half will be sine of theta, and this sine inverse will cancel out each other. So at the end we'll have sine of theta is half. Now, so basically we need to find the value of theta such that the sine of that angle is half. So one thing what I can do, I can draw the curve of sine. So I can try to draw a sine graph. Um, um, let's just draw this line. So sine 0 is 0, so this is 0, and this is sine 90 is 1. So this is pi by 2, and this is pi, then this is 3 pi by 2, and this is, let's say, 2 pi. So the graph looks somewhat like this, and yeah, the maximum amplitude is +1, the minimum is -1. So this is the graph of y equal to sine of x. Now for this case, we know that we need to find the value at 1 by 2. Now with this graph, I don't think that we would be able to find the value. So, well, clearly I know the answer for this graph. That is sine of 30 degrees half. But let's see the solution given here also. So yeah, obviously if you have more coordinates, like if you have the coordinates specified for, like, for y equal to 1 1 by 2, if it is specified that the angle, or the angle is specified for this coordinate, then you can directly get the answer. Or mm, y equal to sine x, so where x is, so sine inverse of x is equal to y, oh, sorry, sine inverse of y is equal to x, which is essentially what an arc sine means. So given that y equal to half, so basically um, sine of 30 degree is 1 by 2, but things are not going to end here, because if you remember, then sine is positive in this first quadrant, and sine is also positive in second quadrant. So if I see, I'm also getting a value here also, and that is going to be it is going to be the sine of this, I guess. It is going to be 180. Basically it is going to be this line. This angle is going to be 30 degree, and this will be 180 minus 30, and this will be, I guess, 150 degree. So this angle will be 150 degree. And yeah, so again we will be getting one more value, which is sine 150 is also going to be half, because the thing is that in this problem the quadrant is not specified, so we have to write both the angles, like where um, like at what points my sine will be plus half. In the question, yeah, in the question they haven't mentioned about the quadrant, therefore the range is only for minus pi by 2 to pi by 2. Okay, but the problem is this can pertain to different quadrants. Arcsine function looks like this. Hmm. Therefore the range is only for, so here they are only calculating in for the case of -90 to +90. um, and yeah, actually it can also exceed, like this graph will continue and we'll have a lot of values, but for the second quadrant and for the first quadrant we'll have positive values. But we also note that half is a positive, therefore the angle is at quadrant 1, which means that the angle we want can only exist in either the first or fourth quadrant and can only be, so this one is also correct here. Like obviously, like if you have this kind of question, it is better to just end it with sine 30, and if it is asking to mention all the angles, then just write 150, otherwise end it till 30 only. I'll just say correct solution would work. Okay, so for the next question, it is saying that how do you find the domain and range of a function in interval notation? So domain and range of a function in interval notation. Yeah, so I will, like it is first thing, it is a theoretical question, so I'm not going to write this theory again because it will take my whole time. So I'll just read the important points, like the domain of a function is all possible values of x where the function is still defined. So this one is important. All values of x where function is defined but yeah, remember one thing, that the function is of x only in this case. Like if we have a function of y, then obviously the we'll be writing y here instead of x. And we find the range, um, for a polynomial function, its domain and range would be the set of all real numbers, so it is going to be from -infinity to +infinity. But we check with the function that at what points there is a breakage, or there the values, like for what values of x the function is not defined, then we exclude those values from the given range. So this is the range of real numbers. So here we have some cases, so I'll just explain the cases. They are basically, I guess, 1 2 3 4 5 6. Yeah, so there are 6 cases, and obviously we can go for the number line representation also. So I'll define with first case. Now in the first case, the thing is that the interval is a finite interval. So it is a finite interval, and it is a closed interval. So this closed and open intervals means a lot. So it says that in notation. So for closed interval we write a square bracket, and for open one we'll just write the normal bracket. So for closed one, a comma b. So it says that my function or the range of the function is from a to b, where values of a and b is also included in the function, and or also included in the range. So let's say this is the number line. I just again make this number line. So let's say this is the number line. Then let's say this is the value a, this one is b, this will go to negative infinity, this will go to positive infinity, and I will use a different color, blue color. So my values of the function are defined in this region, in the blue region, and also a and b also satisfies the function, or the function is also defined at values of a and b. So therefore this is the first case where we have a finite interval and closed one. The second one is finite open interval which is open. So for the case of okay, so for the case of open interval, we write normal brackets. So this is the notation, and again, according to number line, I'll tell you. Let's say this is the value a, this is the b, then my function will be defined. This kind of circle means that the values at this particular point is not included, and for rest of the values, and so for all the values which lies between a and b, not including a and b, okay, for all those values, my function will be defined, or my or all these values are going to be the range, or all these values will lie in the domain of my function. So this means that we are not including a and b. In the first one we included a and b, so I can just make a color dot here, but here it will be a kind of circle. For the third case, it is half open, half close, and that too finite. So that means here also we can have two cases. So half open, half closed means first of all this is finite because it is from a to b. Second, you can see that here a is written with a normal bracket and b is written with a square bracket. That means the value from a to b will be in the range, or will be in the domain. The value of b is also going to be in the domain, but not the value of a. The same applies here. The value of b is not included, but a is included, and all the values between a and b is included. So if I draw a, b, again a, b, then with my blue color a is not included, I'll draw just a circle here, and for b I'll just make it a little bit darker, and this is going to be my number line, and for here a is included, b is a circle. So this will be such kind of line. Again, I just, yeah. So this is the half open and half closed interval where plus finite interval obviously. Now we have three cases with finite. We'll be having three cases with infinite. Okay, so these cases are also going to be the same. Sorry. Mm, this one is fourth one, and that was it. That is infinite and closed. And closed. So this is infinite and closed is easy. Um, Basically, okay. So for this, again, we'll be having two cases. And let's say we have here we have B, and let's say here we have A minus infinity, positive, positive, negative. So for this one, infinite and closed, I don't think that infinite and closed. Okay, yeah, I was right. So basically, we never write a square bracket with infinity because the thing is that infinity is a not defined number. We cannot include the value. We cannot just write infinity there. So therefore, we always write infinity with a curly bracket, and here B is so, and it is again a closed interval. Here we'll be writing a square is needed, and for that too is positive infinity in curly bracket. So here B will be included and it will go, so this line will go till minus infinity, and here also A is included and it will go to plus infinity. uh, it will keep going on. So again I'm repeating that in the case of infinity, we do not include the infinity, or we do not write infinite in the square bracket. That was fifth. This is going to be fifth one. So for fifth one, we have infinite and open loop. Okay, this is infinite and open loop. Again, we'll have two number lines here. Again, first one will go with B. Second one will go with A. Now, in the previous case, already told you that we'll not include in or will not um, write a square bracket with infinity. So in the case of closed one, we just operated the closed or square bracket at finite terms. Here we'll again operate the open or the curly bracket with finite terms also. Like obviously it is included with infinity, but yep, we'll be writing it with finite terms also. So here it will be minus infinity till B, but B is not included. Here it is A from infinity, but A is not included. So I'll draw a circle here. That means A and B are not included, and this is from minus infinity. This one is to till plus infinity. And last is infinite and open. So that is the case for real numbers. Sixth one is and open. Well, in the last case or in the previous two cases, they should have written like infinite and closed finite and infinite and um, uh, open finite, because infinite and open, we have two infinite and open which will, like, it can clash with each other. But so infinite and open, again this is the number line, minus infinity to plus infinity. I'm not going to draw with blue here because, yep. So infinite and open will be from minus infinity to plus infinity, and that is also the range of all real numbers. Basically all real numbers are from minus infinity to plus infinity, and again I'm not going to draw blue line because it will just overlap with this red color. So I guess that was all for this question. This was a lengthy question and was question number 3. I'll just first write correct solution here. Nice work. This will be question number 4. Some questions take a lot of time because they require more explanation, but some of them are very short, just like this one. So we need to simplify the expression. It is negative of sine square x plus cosine square x, and yeah. So for this one, what we'll do, we'll use the property of trigonometry, which is sine square x plus cosine square x equal to 1. We'll just substitute the value of this, so it will become, and the final answer will become negative of 1. So again, we can simplify the given expression by using Pythagoras trigonometric identities, sine square. Then see, the last question took a lot of time, and this one was took maybe a minute. So correct solution is given here. Nice work. I guess this will be question 5. I guess, yeah. Mm. So this one is Q5. So how do I calculate the angle between two vectors? So angle between two vectors. Um, First we'll go with the definition here. So let's say we have two vectors. A vector which is a1, a2, an. Then we have b vector which was b1, b2, and then b1, b2, bn. So to find the angle between them, we use the geometric definition, or we use the definition of dot products of vectors. So it says that a dot b, or the dot product of a vector, is magnitude of a times magnitude of b times cosine of theta, where theta is nothing but angle between them. So I'll just explain you with an example. So let's say I have a vector a which is 2i plus 3j plus 4k, and let's say b is what should be b? Let's say b is 3i plus 10j minus 13k. So first we need the LHS part, which is the dot product. So we'll go for a dot b for a dot b. So if you are not good with dot products, then it is I dot I is 1, j dot j is 1, k dot k is 1, and I cross j is 0. Sorry, I cross j is k. So I dot j is 0, j dot k is 0, and I dot k is 0. So we just multiply the constant of item with the constant of the other I. Like here, I'll just multiply 2 with 3 only. If I multiply 2 with 10, then I dot j will give me 0. So I won't be operating that. So dot product will be 2 into 3 plus, again here I dot I is 1, so I'm not going to write this one also. This will be 3 into 10 plus, this will be 4 into negative of 13. This will become 6 plus 30. This will be probably minus 4 into 13. It should be 52, yup. And this will become 36 negative of 16. So our A dot B is negative of 16. Now we'll go for the magnitude of both the vectors, because according to this formula we need magnitudes of both of them. So for magnitude, um, it is nothing but square root of 2 square plus 3 square plus 4 square. So 2 square plus 3 square plus 4 square, and then square root of answer. So it is 5.385. And then we have the second one, which is B, and that will be where was I? Yep, that will be 3 square plus 10 square, and that is plus minus 13 square will be positive only, doesn't matter. So it will become 3 square plus 10 square plus 13 square, square root of answer, and that is 16.673. 16.673. Now I'll just go with the formula. So cosine of theta will be A dot B over magnitude of A times magnitude of B. So that will become A dot B was negative 16. Obviously this angle, I think this angle is going to be in either second quadrant or either fourth one, because theta is going to be negative here, and this is 5.38 into 16.673. This is 5. This is into 5.385. This will be negative of 16 over 89.7858. So minus 16. No, 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 no. Minus 16 divided with answer, it will give me cosine of theta will be negative of 0.1782. Then I can take cosine inverse on both these sides. Then theta will become cosine inverse of negative of 82. Then cosine inverse, yep, cosine inverse of negative of 0.1782, that is 100.264 degrees. So it can be something like this was one vector, let's say a vector, and let's say 90 will be this, so this was b vector, and the angle between them was 100.264 degrees. So basically in this way we can use the property of dot product, or we can just use the formula of dot product, solve it for cosine theta, then find the um, dot product, find the magnitude, put it in the equation, and do the cos inverse on both the sides, and definitely you will be end up with the angle between them. And in cases where the um, angle between them is 0 degree, in those cases you will get this the a dot b, I think you will get no, 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 a dot b over magnitude of a and magnitude of b will be 1. Basically a dot b will be equal to the sum of these magnitudes, and obviously you will get cos theta equal to 1 when theta is equal to 0. So like vectors are aligning with each other, or they have the same direction. So I guess this was question number 5. And yeah, that is all for this question also. So correct answer. Good work. We'll be going with question 6. Mm, So in this question, it is asking that what are half angle and double angle identities? Okay, I'll just read the definition first. I'll just write it. Half angle and double angle identities. Now the formula obtained by considering the half of the trigonometric functions as half of the original angles is named as half angle formula. Okay. Depending on quadrant in which the half angle lies, consider cos 2x equal to 1 minus 2 sine square x. Let x equal to x over 2. Then the half angle formula for sine function is obtained as they have just manipulated. Okay, half angle for cosine, and here they have calculated half angle for tangent function, and double angle formulas, double angle cosine. First I'll start with double angle because they have obviously given a very lengthy solution here. So first I'll start with the double angle because like people are more familiar with double angle identities. So double angle. So it double angle identities are basically, so for example, if you have let's say sine of 30 degree, cosine of 30 degree and tangent of 30 degree, and you want to calculate the trigonometric ratios for 60 degree, which is double the angle which you or whose trigonometric ratios you already know. So in that case, we use double angle identities to find the trigonometric ratios for the like double the angle. So it is like uh, from the name itself, it clearly states that if we know the if we know the half of the angle, or if we know the trigonometric ratios for half of the angle, we can calculate its double, or we can just calculate like its double the trigonometric ratio for its double angle. So like there is also not pretty much to explain. So sine, let's say 2x. So again, if I have the trigonometric ratios for sine x, cosine x, and tangent x, then I can write sine of 2x will be sine square x 2 times, sorry, not sine square x, it will be sine x only, 2 times sine x times cosine x. For cosine, we have cosine square x minus sine square x, or 1 minus 2 cosine square x, or for cosine we have three formulas. I don't know why, but cosine gets a special kind of treatment, minus 1. For tangent we have tangent 2x is 2 times of tangent x over 1 minus tangent square of x. Now for obviously we have derivations for sine 2x, cosine 2x, and tangent 2x, which you can clearly see in this solution also. I can also go with this. Let's do the derivation of sine 2x. Then I will do the derivation of cosine for the first one, and then tangent. Okay. So the formula for sine a plus b is sin a cos b plus cos a sin b. So I'll just put a equal to x and b equal to x. That will become sine 2x. So this will be sine of 2x will be sin x cosine x plus cosine x sin x. I'll just write this a equal to x and b equal to x. Now again, I can say that this is nothing but 2 sin x cosine x. Similarly, we'll go with the cosine. So cosine of a plus b is cosine a minus sine a and then sine b. Again, I'll put a and b as x. This will become 2x, and this will become cosine x, again cosine x minus sine x, and again sine x. So this will again be can be written as cosine 2x is these two terms can be multiplied, and it will be cosine square x minus sine square x. And then you can use the property like sine square plus cosine square equal to 1. You can solve it for cosine square, then you can solve it for sine square and put the value of those terms here, so you will get the other two formulas. Tangent of a plus b is tangent a plus tangent b over 1 minus tangent a tangent b. Again, I'll put a and b as x, so this will become plus tangent x over 1 minus tangent x times tangent of x. So this will again can be written as tangent square x over 1 minus, sorry, 2 tangent x, 2 tangent x over tangent square x. Now we'll go for half angle identities. So in the case of half angle, so earlier I was talking about if you knew the trigonometric ratios for 30, then you can calculate for 60. You can do the opposite also. So if you know the trigonometric ratios for 60, you can calculate it for 30. Like these kind of practices we do to find the trigonometric ratios of, let's say, 15 degree and then 7.5 degrees, um, if we do not have a calculator. But like in engineering applications we always use calculator because we don't have the um, time to waste on calculations like this. So um, I already told you the formula for sine 2x, which is 2 sine x cosine x. What we'll be doing is that we'll be putting x equal to x over 2. So this will become sine 2 times x over 2 to sine x over 2 cosine x over 2, and this and this can get cancelled, and this will become sine x over 2 is 2 sine x over 2, sorry, sine x, this will become sine x and cosine x over 2. They haven't done this half angle formula for sine function. Okay, so basically they okay. I will be not using this one, although we can definitely calculate, but here we have two sine, we have sine and cosine also. We'll use the cosine 2x equal to 1 minus 2 sine square x. Yeah, so here we have only sine and one cosine. Yeah, so this will be easier. We'll put x equal to x over 2. That will become cosine of 2 times x over 2 to 1 minus 2 times sine square x over 2. This and this can get cancelled, and we'll have cosine x equal to 1 minus 2 sine square x over 2. Now we'll be solving this for sine x over 2. So I can take this term here and this one here. So it will become 2 sine square x over 2 equal to 1 minus cosine of x. Again x, let's say x, you have 60 degree and you wanted to calculate for 30, then this will become 60 by 2, which is 30, and then you can just calculate. So we'll be dividing both the sides with 2, and this will become sine square x over 2 is equals to 1 minus cosine x over 2. Now we'll take the square root on both the sides. So finally we'll be ending up with 1 minus cosine x over 2. Similarly we can do for the cosine. Again I'll take cosine 2x is nothing but 2 cosine square x minus 1. Then I'll put x equal to x over 2. So this will become cosine of x, and this will become 2 cosine square x over 2 minus 1. And then I'll take 1 on this side, and I'll just flip this term, so I'll just write it like this. x over 2 equal to 1 plus cosine x. Again, I'll divide both the sides with 2. 1 plus cosine of x over 2. I'll take square root on both the sides. So this will become cosine x over 2 is square root of 1 plus cosine x over 2. Um, Again, this is a very lengthy question. Okay, so this was cosine x over 2. Yeah, at last we'll be doing with tangent also. So tangent of 2x was 2 tangent of x over 1 minus tangent square x. In this case, I think we'll be getting a quadratic equation. I'll just cross check this. Okay, so instead of going with this one, we'll write, this was easier, yeah. X over 2 is sine of x over 2 over cosine of x over 2, and we have already calculated sine of x over 2 will be square root of 1 minus cosine x over 2 over cosine x over 2 was 1 plus cosine x over 2. This 2 and 2 can get cancelled, and this will become square root of 1 minus cosine x over 1 plus cosine x. Let's just check this. And now what they have done, okay, so they have rationalized also. We'll do the rationalization. So we'll do the rationalization with the 1 minus cosine x over 1 minus cosine x. This will become, in the denominator we'll get 1 minus cosine square x will be sine square x. This will be 1 minus cosine x whole square over sine square x. This is operated on both them. And finally, I guess we'll just this will become 1 minus cosine x over sine x. So I guess finally we have done this one. This was a very lengthy question, seriously. I'll just write correct solution and move ahead. Correct solution. Great work. This was question 6. Now we'll start with question number 7. Oh, this one is very easy. So we need to simplify cosine x over sine x. Well, that is tangent of x. Let me just see what they have achieved at the end. Okay, yeah, cotangent. Okay. So let's say we have a triangle, right angle triangle. I'll erase all the extra parts. And let's say this angle was x. So according to this angle, this will be opposite side, and this will be adjacent, and this will be hypotenuse. cosine x is adjacent over hypotenuse, sine x is opposite over hypotenuse. So we'll put the value of cosine x and sine x in back in this equation. So this will become adjacent over hypotenuse times the inverse of this will be hypotenuse over opposite. Hypo and hypo can get cancelled and this will become adjacent over opposite, which is this one over this one. Now tangent of x will be opposite over adjacent. 1 over tangent of x is cotangent of x. That means cotangent of x is adjacent over opposite, and we have already adjacent over opposite. So we can just write sine, sorry, not sine, it will be cosine. Cosine x over sine x is adjacent over opposite is cotangent of x or 1 over tangent of x. So I guess this is the solution. I guess, yeah. So this is the solution and the solution given here is correct. So I'll just say correct solution. Good work. This will be question number 8. I guess this is a final question. So it is saying that how do you graph the function y equal to x? Okay, so question number 8. Look, for such kind of graphs, we have various methods to graphs this straight line. So first of all, I can clearly say that this is a straight line. One method is I'll take a general equation of straight line, which is slope intercept form. So this is y equal to mx plus c, where m is slope and c is y intercept. So here, if we just compare both of these equations, then I can say that for the given problem, c is 0, m is equal to 1, and m is nothing but tangent of theta. So theta is nothing but a tangent inverse of m, and that will be tangent inverse of this will be 1. That means my theta is going to be 45 degrees, because tangent inverse of 1 is 45 degrees. And yeah, so basically I have got the angle and I have got the intercept also. So this straight line is passing through the origin and it has a slope of 45 degrees. Now this is one of the methods from which you can graph this equation. The other method is, you can clearly see that this is a straight line first. So what you can do, you can just input some values of x and see that what is the outcome of that. So for I'll just draw this. So for example, x equal to -1. If I put -1 here, then y will become -1. If I put -5, then again y will be -5. For 0, it will be 0. So basically whatever is the value of x, it will be the value of y itself. So it is 1, 5 and 1 and 5. So for now I'm going to draw the axis system. This is y, this is x, this is the origin 0. Now from the first method I can just draw a straight line from origin, making an which is making an angle of 45 degrees with the positive x-axis. Yep, so and this is 45 degree, and again it will be continued till here, and this is 45 degree. So from the first method the straight line will look like this. From the second method we can just plot the coordinates. I'll take green color this time. Y, x, 0. Let's say this is -1 and -5. This is 1 and 5. This is also 1, 5, -1, -5. So for -1 it was this one, it was this one. For 0, 1, and for 5 it will come somewhere here. I'll just draw a line from all this. Yeah, there is some kind of error. Yeah, but so again we are getting the same exact graph. So these are two of the methods from which we can draw a straight line. I'll just check here. So they have followed the first method, and so a point will be 1 comma 1, and yeah, so that is, I think that is all for this question. So I'll just write correct solution. Good work. And the solution is correct. Yeah, so that is all for this session. So if you like this session, then please do hit the like button, do subscribe to our channel, and do hit the bell icon so that you will be always updated with our next live streams. And again, this was Devansh, senior tutor at OneClass. And if you want to submit your own questions, or if you want any tutoring help or one-to-one live sessions, then you can always check the links in the description below. And I hope to see you soon in my next video. Till then, bye.